Once again, we're going to look at an example of a proof using angles. In this particular proof, we're going to look at showing that two lines are parallel. And you might notice this proof. This is a proof that you maybe would see later on in your geometry class having to do with parallelograms. It starts off by saying if angle RSP is congruent to PQR, and so you're given that RSP is congruent to PQR, and QRS is and PQR are supplementary. And so this angle here with your PQR are going to be adding up to 180. Then you want to prove that PS is parallel to QR. So again, let's go ahead and start first before we discuss some of our options with just getting our given statement out of the way, saying that RSP is congruent to PQR and QRS and PQR are supplementary. Those are our two given statements. That's what we're, where we start. And we will look to see how can we use those given statements to prove what we want to prove. Well, let's first start by talking about what must be true if we want to show that PS is parallel to QR. So what must be true for these two lines to be parallel? Well, there are a couple options for that. One is to recognize that RS could be considered a transversal. If that was a transversal, then if we could show that QRS and RSP are supplementary, then by the converse of the same side interior angles theorem, you would have parallel lines. Or you could notice that QS could be a transversal, and RQS congruent to PSQ would also be enough to show that the lines are parallel by the converse of the alternate interior angles theorem. So we're going to do one of those two. So let's look at what we have. We're given that RSP is congruent to PQR, and we're given that QRS and PQR are supplementary. Well, having this supplementary thing tells me that maybe I should go ahead and see if I can show that RSP and QRS are supplementary as well. And it turns out that it actually is going to be pretty easy to do, because based off our given statements, we know that measure of angle RSP equals measure of angle PQR. And that's just definition of congruent angles. And also from our given, we know that measure of angle QRS plus measure of angle PQR equals 180. And the key thing to notice there is that both of those statements include PQR, so a substitution seems like it would make a lot of sense. And by the way, this was definition of supplementary angles. And it does turn out that we can do a very easy and nice substitution, which allows us to say that measure of QRS plus measure of angle RSP, there's our substitution, equals 180, which is just by substitution. And that was really good, because now we've shown that angle QRS and angle RSP are supplementary. And that, just by definition of supplementary angles, and that turns out to be enough, as we talked about, to make our claim. If QRS, if this angle is supplementary to that angle, RSP, then that means that the lines RQ and SP are parallel, which is what we wanted to show. RQ parallel to SP, and that is by the converse of the same side interior angles theorem. Which states that if same side interior angles are supplementary, then the lines are parallel. Now, there were some other ways you could have done this with some substitutions. One thing is to notice that because these two were supplementary, that meant that RS and PQ are parallel by the converse of same side interior angles. So you could have shown that as your step 2, which would then give us that this angle is congruent to that angle. And then from there, you could have done some different substitutions using the angle addition postulate to show that if we, we could do it this way, if we called them angle 1 and angle 2 and angle 3 and 4, well, RSP equals 1 plus 2 and RQP equals 4 plus 3, but we could substitute those in for here, and then we could do the substitution of 1 in for 3 and show that 4 is congruent to 2 that way by setting things equal and simplifying. So that would have been another way to go about doing this proof. But the way I did is probably the best way to get to an answer.